Good morning, students. Today we are going to discuss about computing information against continuous valued attributes. Last class we discussed about information gain. Whatever the information we discussed, that thing we discussed about discrete valued attribute we seen in given table. Here, what happens if we have a continuous valued attributes under information gain? See, let attribute A be a continuous valued attribute, must determine the best split point for A. See here, according to that information gain, previous class it will concentrating whatever the attribute we are facing, that should have larger values, then only the information will be gaining over there based on larger based on highest value. Here what happens if we have continuous valued, how we will going to get the best splitting point based on given attribute A here. So let attribute A, continuous valued attribute, must determine the best split point for attribute A here. Sort the value A in increasing order. First, initially we need to sort the value in increasing order. Then once we sorted, here we are getting like a midpoint between each pair of adjacent values is considered as possible split point. Initially, once we sorted increasing order, then obviously we need to make a midpoint between each pair of adjacent values is considered as possible split point. See, that is AI plus 1 divided by 2. Obviously, as we know that how to get midpoint means, obviously we are going to merging the things. Then once we merged whatever the value we have generally, then we need to divide by 2. With that we are going to get the midpoint values here. Like that, here AI plus 1 divided by 2 is the midpoint between the values of AI and AI plus 1. This way we are going to getting midpoint. The point with the minimum expected information requirement for A is selected as the split point for A. See, as we know that, like here, the point with minimum expected frequency, here we are not concentrating maximum expected frequency, here concentrating minimum expected not frequency, minimum expected information requirement for A is selected as the split point for A, because according to that information gain, based on discrete valued whatever the attribute we got larger value, obviously with that thing we are going to splitting the remaining contents. Here we are expecting minimum expected information, based on that thing we are going to splitting the A. Split D1 is a set of tuples in D satisfying A less than equals to split point, and D2 is the set of tuples in D satisfying A greater than split point. With this we are splitting the contents. The next concept is gain ratio for attribute section. Here, according to that information gain, we are concentrating higher value here. According to the gain ratio for attribute selection, information gain measure is biased toward attribute with a large number of values. As I told that, information gain, it's concentrating a larger number based on whatever the attribute we have selected. With that thing, obviously if that content what we chosen, like whatever the attribute we chosen, if that contains larger value, obviously that will be chosen as a best split point. For the sake of creating a tree, with that thing we are going to generating certain kinds of trees over there. See, according to this see 4.5, a successor of ID3, as you know that ID3 is nothing but iterative dichotomizer, uses gain ratio to overcome the problem normalization to information gain. According to this thing, like a gain ratio, we are splitting the information in split info of a of d equals to minus summation j equals to 1 to v modulus of dj divided by modulus of d into log 2 modulus of dj divided by d. Here, according to that gain ratio of a selected attribute, like attribute selection, instead whatever the parenthesis you are observing here, inside that particular content can act as a attribute here, equals to gain of a divided by split info a of d. Example, see, last class we discussed about information gain based on that particular given problem. We have 14 tuples in given like table. One thing is age like age attribute is there, income attribute is there, like class labeled base computer attribute is there. We have certain kinds of things, so based on that particular thing, like age attribute, income attribute, student attribute, credit rating, and then class base computer. Each and every attribute contain their own set of values. We discussed already about that particular problem in previous classes, in previous video. See, like that, according to that particular concept here, split info a of d. A in the place of, you want to observing here, in the place of a we replaced income. Income can act as the attribute. As I told that a is nothing but attribute income of d equals to, see, that particular income attribute contains, as I told that certain, each and every attribute contains their own set of values, here. Minus 4 divided by 14. 4 is nothing but whatever, like here according to that table 4 high values are there. According to that formula, minus 4 by 14 into log 2 4 by 14. Split info, you might observing here, they have given a problem like a formula, minus summation of j equals to 1 to v dj by d into log 2 dj by d, like that, like minus 4 by 14 into log 2 4 by 14 minus, here 6 belongs to medium value, then 6 by 14 into log 2 of 6 by 14 minus 4, again minus 4 belongs to low value. See, minus 4 by 14 into log 2 4 by 14. Once we calculated this thing, we'll get the 1.557 value. Then if you want a gain ratio of a particular attribute, whatever the attribute you have chosen, gain ratio of income, with that formula we need to divide the thing to check the what value we are getting over there. Gain ratio of income equals to 0.029. How we got this particular 0.029 means we already solved in previous classes about income attribute. Gain of income we got 0.029. Based on that thing, we are considering that value here, 0.029 divided by split info income of d. We got 1.557 value. Then once we divided these two things, then we will get the 0.019. The attribute with the maximum gain ratio is selected as the splitting attribute. Here also we are considering maximum gain ratio, whatever the value, whatever the attribute it may be. If one of the attribute what we chosen, if that attribute have the value like larger value, then obviously that can be treated as a best splitting attribute to further procedure. Then a Gini index. This is third one under this particular attribute selection measure. If a data set D contains examples from n classes, Gini index, Gini of D is defined as, we have one more formula about the Gini index. Gini of D equals to 1 minus summation I equals to 1 to m pi square. Here I have missed I equals to 1 under given under that formula, sorry for that, where pi is the probability that a tuple in D belongs to class Ci and is estimated by Cij by D. As we know that about pi, this is a probability that a tuple in D belongs to class Ci and is estimated by Cij divided by D. the sum is computed over m classes. M is nothing but whatever the attribute we have, like obviously I told that attribute contain number of values, like attribute, each and every attribute contain their own set of values. Whatever the value we are facing, that value can act as a classes here. We'll discuss as we know that we discussed already in previous classes. If a data set D is split on A into two subsets D1 and D2, the Gini index of Gini of D is defined as Gini A of D equals to D1 by D Gini of D1 plus D2 by D Gini of D2. Then next formula, like reduction in impurity, delta Gini of A equals to Gini of D minus Gini A of D. The attribute provides the smallest Gini split of D or the largest reduction in impurity is chosen to split the node. Need to enumerate all the possible splitting points for each attribute. We'll discuss how Gini index will be working with the help of problems. See, we have that table as we discussed in previous classes. Here D has 9 tuples in Bayes computer equals to S and 5 in no. See, according to that given table, like class label training tuple from the all electronic customer database, that particular database contains age category, age attribute, income attribute, and student attribute, credit rating attribute, and one more is class labeled attribute, that is nothing but here Bayes computer. As I told that each and every attribute contain their own set of values. Here, according to this class labeled attribute, we have 9 S's and 5 in no's. These are values belongs to Bayes computer, class Bayes computer. According to that particular Gini formula, like Gini of D equals to 1 minus summation I equals to 1 to m pi square. Based on that thing, 1 minus 9 by 14 whole square minus 5 by 14 whole square, because 9 belongs to S category, then 5 belongs to no category, because we have two classes here. According to that formula, 1 minus summation I equals to 1 to m pi square. M is nothing but, as I told that, m is nothing but distinct classes here. Like that we have two classes S and no. 1 minus 9 by 14 whole square minus 5 by 14 whole square. Once we calculated these particular values, then we will get the 0.459 that belongs to Gini of D. Suppose the attribute income partitions D into 10 in D1 low comma medium and 4 in D2, because whatever the income attribute we have, if I can say like this, like income contains like 3 kinds of values here: high, medium, and then low. That particular income attribute contains high, medium, and then low. Suppose that attribute income partitions D into 10 in D1 low comma medium. Here low comma medium can act as a subset for particular income attribute. We are making subsets here: low, medium, and 4 in D2. Here Gini income belongs to low comma medium of D. If I can make, if we made subsets of particular attribute, whatever the attribute we are facing, then income belongs to low comma medium, because belongs to here, obviously low and medium can act as a value for that particular attribute. That's why we are using belongs symbol here, because obviously those two values belongs to that particular income attribute of D. See here, low comma medium, how many yes and then how many no's are there for that particular thing. Just not no, like how many like low and then how many mediums are there. We need to count it under that given attribute: 1 2 3 4 5 6 7 8 9 10. See, total combination of low and medium we have 10 values, then 10 by 14 Gini of D1 plus 4 is nothing but this one more attribute, that is high. Here 4 number of highs are there, high, that's why we are considered 4 by 14 Gini of D2. Then here 10 by 14 Here 10 by 14 as it is we considered here. According to that Gini of D1, we have a formula of that. As you know that Gini of D equals to 1 minus summation I equals to 1 to m pi square. Based on that thing, just concentrating, we are concentrating first part like LHS part. 10 by 14 Gini of D1, still we are concentrating that particular thing here. Gini of D1, as you know that, like we need to count how many is, then how many no's are there belongs to that particular subset, low, comma, medium, under class labeled attribute by computer. We need to check it over there, because here according to that particular thing we have 1 2 3 4 5 6 7 total 7 S's here, then 3 no's for low and medium. 10 by 14 of 1 minus 7 by 10 minus 3 by 10. 7 belongs to S, 3 belongs to no, plus 4 by 14 1 minus how many, like we have one more attribute under that income attribute, like one more value under that income attribute, that is high. How many no's and then how many S's are there under that class labeled attribute by computer, we need to check. Then we'll get 2 S's and then 2 no's for high value in income attribute. Then once we calculated, we'll get the 0.443 value. Gini income belongs to high of D. Gini, see, that is the value of a Gini income belongs to low, comma, medium, 0.443, like that. Once we partition, like once we made other subsets Gini of low, comma, high, then we'll get the 0.458. Then once we made other subsets again Gini of medium, comma, high is 0.450. You might observing here 0.443 low, comma, medium, 0.458 low, comma, high, 0.450 medium, comma, high. The split on the low, comma, medium and high, since it has the lowest Gini index. Low, comma, medium have lowest Gini index, because here all the attributes assume continuous valued, may need other tools. Example clustering to get possible split values can be modified for categorical attributes. Here this is about Gini index. Thank you. Remaining things we'll discuss tomorrow.